Hello everyone, welcome back to my channel. I am Adi and today we are diving into one of the most efficient searching algorithm, the binary search algorithm. So let's get started. Linear search. In linear search, you start at the beginning of the list and check each item one by one until you find what are you looking for. It's simple and can be used on both sorted and unsorted lists. Linear search is pretty straightforward but can be slow. Its time complexity is O of n. Here is how it works. Imagine we have a list of number and we want to find the target 9. Step 1, start at the beginning of the list, look at the first item 1, it is not 9. Step 2, move to the next item 2 and it is not 9. Then 3, then 4, then 5, then 6th iteration, 7th iteration and 8th iteration, and then we found our target item 9. So in this case we found 9 after checking 9 items. Now this method works fine for a small list like this one. But imagine if our list had thousands or even millions of items, we have to check each of the item one by one, which could take very long time. Binary search. On the other hand, binary search only works on sorted list. It splits the list in half to see if the target is in upper or lower half, repeatedly narrowing down the search area until it finds its target. It is much faster than linear search for large type of list because it cuts the search space in half each time. Let's break down the steps of binary search with an example. 1. To find the position of the number 9. Step 1. Start with the entire list. The middle element is at index 5. That means in the list it is 6. Step 2. Compare 6 and 9. Since 9 is greater than 6, then we discard left half of the list. Step 3. Now our list is 7, 8, 9, 10, 11, 12. The middle element of the index is at 2. That means 9. We have found our target. And that's how binary search efficiently find the position of number 9. Binary search is different. If the list is 100 times long, it takes at most 7 guesses. If the list is 4 billion times, it takes at most 32 guesses. Powerful, huh? Binary search runs in logarithmic time. Each step, we divided the search interval in half. So, in the worst case, the number of steps required to find the target or conclude its absence is proportional to the logarithm of the number of the elements in the list. Let's break this down. If you have one element, it takes at most one step. If you have two elements, it takes at most two steps. For four elements, at most three steps, and so on. This logarithmic growth means that even for very large list, the number of steps remain relatively small. After k of iteration, the size of the array becomes 1, narrowed down to the first element or last element only. I have a dataset that I collect from Kaggle. It's almost size is 400. Now let's see the use of binary search algorithm. First we have to import JSON because we need to read the JSON file. After reading the JSON file, now it's time for binary search algorithm. We take the list and the target. Now low value is C0, high is len of the list -1, while low is less than or equal to high. Mid value is low plus high divided by 2. Now the guess variable is list of mid value of id, because we need to extract the id. If guess is equals to target, return what? Return id equals to we have data that we read from JSON file, data mid and its id. id, then name, country and transaction. id, name is data of mid of name, country, data of mid of country. I think country is not important. We see the transaction. You have to do this. Data of name of this one. Okay, if guess is greater than target, then high is equals to mid -1, else low equals to mid +1. Either id not issued yet. Now let's check is it working or not. Binary search, step data. Let's take the random number, random dot range 0 to, we have 400 data, so 0 to 399. So let's check Python 3 use of base. So we get the ID 267, name is William Miller, and transaction is 2000 27,000. So ID number is 267. Let's check 267 William Miller. That's how binary search is practically used.